In the next 1 hour, we will be learning about how can SQL Server 2016 make lives of developers easier. I would request all of you to silence your cell phones. If you get a call, you can go out so that you don't disturb the persons beside you. Thank you so much. Again, PAS has a lot to offer, be it with the SQL Saturdays, with the local user groups, the virtual chapters, be a volunteer. There are a lot of online resources. I would recommend you to take the most advantage, the most benefit from those resources. Session evals, very important for speakers, very important for the summit as a whole. So make sure that you put in your session evals in time. Again, I have presented this particular presentation in multiple SQL Saturdays this year. And I must admit that the folks who came to my session, most of the time, they end up winning the big raffle prizes at the end of the day. So you all can get lucky. Make sure you put in your evals in time, and yeah, you might win something. Little bit about me. I am Samir Behara. I work as a senior developer in EBSCO Industries, Birmingham, Alabama. I have 12 years of experience in multiple domains like publishing, manufacturing, insurance. I do a lot of my work day-to-day in C#, .NET, and SQL Server. I'm basically a full-stack developer, and that's what I will be focusing on during this presentation as well. I'm also the co-chapter lead of the Steel City SQL Server user group. I have my chapter lead, John Baldwin, out there. Just came on at the right time, John. I'm also the author of .NETVibes.com, so all the content in the slide, if you want to go in depth, everything is on my website. My Twitter handle is Samir Behara. Again, I'm talking at the PAS Summit for the first time. So if you want to tweet out some pictures, you're more than welcome. I love SQL family. Thank you so much. What are the things which we will cover during today's session? So we will be focusing primarily on 3 areas: performance, productivity, and security. So from performance standpoint, we will look at live query statistics and query store. We will cover JSON support, temporal tables, and we'll look at some of the cool T-SQL enhancement which are there in 2016. And from security standpoint, we'll look at dynamic data masking. Again, I just have 60 minutes to cover these 6 topics. There's a lot of content, a lot of demos, so I'll try to do justice to all these topics. If you have any additional questions, I can stop by after the session. I'll be available. We can talk, and I can show you some additional demos and answer your questions if you have. I'll start with SQL Server Management Studio version 17. So how many of you are actually using version 17 at this point? Awesome. Anyone using SQL Server Management Studio 2014? Okay, good number of folks. Again, starting with SQL Server 2016, what Microsoft did was they have decoupled the SSMS IDE from the core server engine. So SSMS is a total separate installer at this point. It's not tied up with the engine. It's you can go ahead, download the installer, and it's a three-click installation process. And no matter if you're still running on 2008, R2, 2012, 2014, you can still use SSMS version 17. We have a lot of monthly updates coming up. There are code fixes. There are new enhancements coming every month. You get automatic updates. So I would highly recommend you to go ahead and install version 17.3 if you have not done it. So some of the cool enhancements which came up with version 17.3, which got released on October 10th, There are two new features, import flat file wizard and the built-in X event profiler. So pretty cool stuff, which is there in 17.3. In 17.2, we got a lot of additional features like searching in execution plans. We had the built-in performance dashboards as well. And again, if you look back on 2016, 2017 version 1, you have additional features like comparing execution plans. There are a bunch of improvements on the execution plan window, the new installation experience, the vertical scroll bar enhancements. And once you download 17.3, the best part is it uses the Visual Studio 2015 behind the scene. So till 2014, what was happening is it was still using the Visual Studio 2010 shell. So that was the main reason why there was so much of technical depth which was accrued with SSMS over a period of time. So for any developers who are working with .NET and they see Visual Studio 2015 and then compare it with SQL Server Management Studio 2014, they used to see so much of difference. But now, I guess, since both of them are, since at least SSMS is using 2015, and hopefully in very recent future, it will use 2017 shell. So you'll get the same experience, well, apart from the dark theme, which is still not out. So we'll start with the first feature, live query statistics. Again, how many times have we as developers, DBS, we have run a query and it just runs, and runs. We see, okay, what's happening? You leave the query for 30 seconds, 1 minute, 2 minutes, 3 minutes, it's still running. You'll say, okay, I don't know what's happening. Let me go ahead and terminate the query. Again, there might be multiple reasons why a query might take long amount of time to run, right? You might have joined 10 tables, 5 views. You might not have joined it correctly. You might not have joined it on the indexed columns, or your tables might be large sized as well. But how do you troubleshoot a query performance issue? Generally, as developers, what we will do is, okay, I'll run a query. I'll generate the execution plan. I will start looking at the execution plan. I'll try to find out if there are any table scans, index scans, any key lookup operators, and then start tuning it from there. But what about a long-running query which never completes, and you have to terminate it before even the execution plan is generated? How do you troubleshoot it? The only way at this point is, like, if I have a long query, long complex query, I'll try to trim it down, say remove 5 tables, and try to play around and see which table might be causing the problem, right? But with 2016, that problem goes away. We have a new feature called as live query statistics, which makes life so much easier. So this is how a GIF image actually of how what you will see when you enable live query statistics. So the query is running, and we can see, okay, the executing query percentage is 45. If I look at the operators here, I look at this guy, 99%, 100%, 73%, 99%, 45, 99, 100, and this guy is still sitting at 7%. The clustered index scan on product model table is sitting at 7%, whereas all the other operators have completed. So the query is still running. It has not completed execution, but I know exactly what is my pain point. So I will look into that operator and try to fine-tune it from there. So what are the benefits of live query statistics? Basically, whenever you bump into a long-running query, say you are using ORMs like an object relational mapper, like Entity Framework, Dapper, and what they do behind the scene is fire long queries, right? All of us know that. So if you are trying to troubleshoot such a long-running query and you get stuck, use live query statistics. Real-time insights into SQL execution process. Again, when you fire a SQL query, there are a lot of things which happens in the background. You have the relational engine, which where actually the query is parsed. Like SQL will verify whether the syntax is correct, and then you have the query optimizer, which will evaluate the query. It will try to see, okay, it will generate multiple execution plans, and it will go with the execution plan which has the lowest cost. And then once that process is done, it will store it inside the plan cache, go to the storage engine, fire it against the database. So looking at the live query statistics, you will actually get a feel as to how the query optimizer is actually doing its work behind the scene, because you saw all those dotted lines. It tries to tell you, okay, which operator is taking more time, which has already completed. Yes, sir?
Will it suggest indexes before it's finished running?
No, I don't. Yeah. Good question, though. I would love it if it's there in some future versions. And visually track. What he said was, will it suggest an index when it's running? I said, yeah, it won't at this point. And the third main advantage is visually track overall query progress. Again, think about scenarios where you stop a query at 2 minutes time, but you have no idea how much the query actually has completed. It might have completed 99%, and if you had waited for 2 more seconds, the query would have completed. Now you actually know that, okay, the query has either completed for 30%, 40%, 50%, and then you can take an action accordingly. How to enable live query statistics? There are 2 ways. In the management studio, yep.
Does it create an overhead when you're running the live statistics, so it's going to take longer essentially?
No, it won't. It still uses the DMVs behind the scene, but I haven't seen any performance like that. So you can enable live query statistics by 2 ways. So you, in the SSMS IDE, you had 2 buttons, actual execution plan and the estimated execution plan. You now have a new button called as live query statistics. You can include that. Or you can also go to your activity monitor, right-click there, and you can look at all the queries which are running. Right-click and look at the live query statistics as well from there. Yes, sir, you had a question? You can. Yes. Yeah. You can go back till 2005, I guess. But it works with 2000. Yeah. 2005 is, but 2008 R2, everything is great. Yeah.
But does this new feature work with 2008 R12?
Yes, it does work. It does work. So you have to capture it as and when you require. So if you want to enable it before running your query, you turn it on, run it, and then it will be disabled. So it's like, and again, one cool thing about it is if you have SSMS 2016 or even 2017, and you are still, the core server engine is still on 2014, you will be able to see live query statistics. So it's not required to be on 2016, the core server engine to be 2016. If you are 2014 or higher, and you are using SSMS 17, you should be able to see live query statistics. Moving on, we'll go to the next feature, query store. Think about, again, a couple of scenarios. You leave your work at 4 p.m. on Friday. You come back on Monday morning, and all of a sudden, business says that, hey, the home page of your order management system is kind of slow. And you start wondering, okay, I've not done any releases over the weekend. There's nothing pushed to production. There has been no upgrades, no patching. So what has happened? So there might be a lot of times when you would have seen some temporary performance issues. And again, when business comes and tells you that something is running slow, the first thing which you as developers will ask is, okay, do we have any baseline information with us? Okay, how this query was running over the last 1 month or 2 months? And then probably you can figure out whether the query has actually degraded. So when you are doing any performance troubleshooting, it's always important to have a kind of a baseline metrics so that you can look at it, and probably once you are done with your performance enhancement, you can show that, okay, earlier, the query was running for 800 milliseconds, and now, after I did all the optimization, it's running for 200 milliseconds. But before, the problem is, before 2016, what are the options you had to get your baseline performance metrics? You would have to depend upon running some DMVs behind the scene, right? And the problem with DMVs, they are on memory, and they get wiped out after your server is rebooted. So you lose track of all those information. With Query Store, that issue is gone. And what basically Query Store is, it's a new feature in SQL Server 2016, which captures all the execution plans. It will capture all the runtime stats, and it will store right inside your database. So it's always persisted on your disk. It's directly integrated inside SQL Server. You don't need any third-party monitoring tool to decipher any issues because you have everything. SQL Server is capturing all those information inside your database itself. So, and the good thing about Query Store is with DMVs, again, there's so many DMVs around, and you need to know, okay, what to run. Sometimes I go online, fetch some already available DMVs, I run it. But if once you have Query Store, there are new type of reports, UI reports, which you just double click, and it will give you all the information required. So it basically encapsulates all the complexity of running DMVs behind the scene. It still uses DMVs, but you don't have to invest time trying to see if you're running the right DMVs or not. Yes, sir. So the question is, when you are enabling Query Store and it will start capturing information, is it a big overhead on the storage part, right? So again, there are a lot of configuration options available when you turn on Query Store. So you will be able to give it a max size as to, okay, how much size you want your Query Store. By default, it is 1024 MB, but again, you can configure it. I'll show it to you in a demo, what are the different options you have. Great question. Moving on, so what does Query Store do? Yes, sir? Absolutely. So the question is how many days? So that's the configuration options as well. In my demo, I will walk you through that. So what does Query Store do? Just to sum it up, basically it will capture the history of all your execution plans, of all your runtime stats. By default, it stores all the execution plans every 15 minutes and runtime stats every 5 minutes onto your disk. Baseline performance metrics, which I was talking about. Now that you have all the information stored, you can configure Query Store to store information for the last 2 months or for the last 1 month, whatever, as per your requirement. If you're running on some cadence, like if you're in an agile project and you have 2 weeks of iterations and you want to retain your history for 2 iterations, so have it configured to run for 60 days and then flush it out. It will do it automatically. I'll show it on the demo. Okay. So display customizable UI reports. There are 4 reports which came up in 2016. We have 2 more if you download SSMS version 17. You have 2 new reports which are also there. I'll go through them. If you have some performance issues after upgrades, Query Store is very beneficial because you will have the history and you will have how the query is currently running. So you have the execution plans to compare with, and you can go from there. So how does Query Store work? Basically, it has 2 stores, the plan store and runtime stat store. Plan store is what captures all the execution plan, and runtime stat store is what captures all the runtime stats like I/O, how much CPU you are consuming. And again, there were questions in my earlier presentation as to what is the impact on performance. Again, these are async processes. So SQL Server will always give the highest priority to the query to run the query itself. Once it is done, it will save the information, send the information to plan store and runtime stats store as an async process. And that generally, as developers, is someone using queues out here, MSMQ? Does someone use it? Okay, so MSMQ or any queuing mechanism, right, like as, say, RabbitMQ or something, to offload your database safe process to make your applications more faster, what we do is, once we do all the calculation, we will offload the database safe to a separate queue. And that process will now be offloaded. So that way, our application will be more responsive. And we know that even though the data is not yet saved inside the database, but from the UI, I'm already getting a response because that process is now asynchronous. What are the various query store reports which we have? There are 4 different reports. One is the regressed query, which is the most beneficial, I think. This tells you the queries which have degraded, whose performance has degraded over the period of, say, you can configure it, but over the last 2 months, if you want to see which are the queries which have degraded, you will find it out here. Overall resource consumption, so from a overall database perspective, which are the queries which are taking more CPU, you will find it in this report. Top resource consuming queries. Now, as developers, we should always be aware of the top 10, the top 20 slowest running queries in our application, right? And probably at any given bandwidth which we have, we can try to fine tune those and make it more performant. So in this report, it will exactly tell you which are the top 10 slowest running query or top 20. Track query, if there is a particular query which gets executed more number of times, say you have your order management system, on the home page you have a grid, and there's a base query which gets called every time a user comes to the page. So you want to make sure that query performance is optimal. So you can track that query through this report, and it will actually show you how much time that query takes over the period of last 1 or 2 months, however you can configure that. Yep.
Does this work against the 2014 engine?
No, it doesn't. It's a 2016 feature. We'll go to a quick demo. By default, query store is disabled. It's a database level configuration. If you want to turn it on, you have to right-click on the database, click on properties, and this is query store. There are 3 modes: read, write, read only, and off. So if you change it to read, write, what will happen is you will be able to read from the query store, and also SQL Server will be writing onto the disk. Once you say, let me select read, write, and then you will be able to see all the default options which it has. So it says data flush interval is 15 minutes, which means every 15 minutes it is storing all the execution plans onto your disk. Statistics, they are getting stored every 5 minutes. The max size, as you said, you can configure it how much you want. By default, it is 1024 MB. Query store capture mode, there are a couple of options here. You can capture all your queries, or if you change it to auto, basically it will capture only the queries which are having more workload. Size-based cleanup, again, how you want to clean up your query store. You can do it as an auto, and what will happen is once it reaches 1024 MB, it will automatically get flushed. Stale query threshold is set as by default as 31 days. So after every 31 days, it will automatically get flushed. Again, these are the default configuration which Microsoft suggests. If at all you want to change it, you can try it. But keep in mind that if you reduce this interval to say less time, say less than 5 minutes, it will start capturing your information more frequently onto your disk. So you might see some performance degradation. So better to stick with default settings. I haven't seen any issues with that. Yes, sir. So it's stored inside your primary MDF, LDF files. So if you take, the beauty of it is if you take a backup of the database, you'll still find it. If you have a trouble, you want to troubleshoot an issue, so you can take a database backup, put it to some other environment, so you'll still have all your query store information there. That's a good question. It's absolutely. So the question was, it's not accessible. So if you want to bring it to some other environment, you can back it up, restore it, and then access it. That's the way to go with it. So I will turn it on, and once I turn it on, let me refresh it. Yes, sir. So what will happen is, say you have configured the max size of query store as 1024 MB, and you have set the mode as read-write. So once it hits the 1024 MB size limit, query store will automatically change the mode from read-write to read-only. So what will happen is, it will stop writing to your query store, so that because you have already reached your cap, but you will be able to still read information from query store. That's the difference between read-write and read-only. Yes. If you change your configurations, it will. If you flush the query store, it will. So. 1024 is the max, right? It's the default. So you can change it as however you want. Yeah, it will automatically change to read only. Yeah. You have multiple? No. No, you don't have. It's single store for your single database. Yeah. So moving on, I'll just show, you'll get a query store node here, which shows different type of reports. If you right-click the view regressed queries, so whatever queries have degraded over a period of time, you will be able to see it over here. And one of the good feature which is there is you can force plan. If you see that there is an optimal query, there is a query which has run with, say, under a millisecond earlier, and after an upgrade, it's taking more time, you can use this force plan option to force SQL Server to use the earlier plan.
Okay, I have a question for you. Because you're turning it on, I notice that sometimes what happens is when I make a query, they're not my query, but the query is coming from the DMV for their own queries, purposes, whatever. Okay? If that was to happen, can I clean it? Or can I somehow bypass another person's intervention and go after my query and get my question answered?
So Query Store actually uses some new DMVs behind the scene. Now, what you can do is, obviously, you have the option to always flush the query store as and when you need it. So if you want to track a particular query, you can go ahead and configure it and use it from there. Does that answer the question?
Kind of, yes. What I was hoping to have is some type of automation that would clear everything out coming from the DMV. Because then oftentimes I find myself struggling between what I need done immediately and constraints provided from the DMV.
Yeah, so the DMVs, again, it's in memory once you upgrade, once you restart your server, it's gone. That information is already lost. But with these, the query store which you have, if you're running, these use a new set of DMVs, and those are always there inside your disk. Thank you. Just respect to time, probably I will take the questions probably after the session on Query Store. Just run by a few of the other reports. So the top resource consuming queries here. So these are all the queries which are my top resource consuming ones. If you double click here, you should be able to see the execution plans, and you can fine tune it from there. With 2017, there is a new report which is queries with forced plans. So if you have forced any execution plans, you will be able to see it in this report. And this is the tracked queries which I said you will be able to mention an ID of a query, and you can track it for an extended period of time. If there are any more questions on Query Store, probably I would take it after the session so that we can complete the rest of the topics here. Next, moving on, temporal tables. Again, it's a new How many of you have heard about temporal tables here? Awesome. So it's a new type of system version table, which got introduced with SQL Server 2016, and it kinds of stores the entire history of your changes. So till this point, till before 2016, if you want to keep track of your reference data, say of any table which contains your sensitive information, like say auditors come to your place and they audit your project and say, hey, who changed those sensitive information on the employee table? Do you have those information? So generally, you will add a trigger, or you will do some custom coding, right? Developers do some custom coding to track changes on a particular table. They write some stored procs, which are complicated, which takes time, which adds to the project cost. But with 2016, you have a new feature, which is temporal tables, which takes care of all that overhead. It will automatically capture all the changes which is happening on your tables behind the scene, and that's pretty awesome. No, so it will basically capture what has changed on your tables. So if you have a user name column on your table, so that will also be stored, right? Yeah, absolutely.
Is this replacing CDC, change data control?
Not exactly. This is a new feature which requires minimal coding on the front-end side, minimal coding on the database side as well. So it's different technologies. This is a lot easier to implement. So yeah. Yeah. I haven't seen any. I've read through a lot of docs, Microsoft docs. No. Moving ahead. What is temporal? Basically, why is temporal required? The first thing is time travel. So think about, like, we are sitting on November 2nd, and with any traditional database, what it does is it always captures the current state of the table. But if you want to look back on time, say, I want to look at how my employee table looked like 6 months back, the current traditional databases or current traditional tables won't give you that information. But with temporal table, you have that power. You can just fire a query saying, select star from employee where system time as of 6 months back. It will take you to the exact state of the table where it was, like, say, on March 2nd, 2017. So that's the power of temporal tables. Simplified data audits, again, when auditors come to your place and they say, OK, what has changed? Who has changed? So you will always have that history information. So there's no need of taking any backups or restoring backups and trying to find out that information. You can just fire some queries and see what has changed when the information has changed. Trend analysis, business, again, they love doing, they're capturing trends over a period of time, right? They want to see, OK, how the sales has been in October 2017, compare it with October 2016, 2015. So an easy way to do it at this point is temporal tables. Since you're capturing all the changes over a period of time, you can just write some queries, and there you go. You have all the information. Repair corruptions. Now, this is my favorite because, say, how many times have we tried to recover from an accidental corruption? Say I wanted to update 500 rows in my employee table, and by mistake, I wrote the query incorrectly, and I updated 5 million records in the table. So what do? I fire that query at 10 a.m., and then there's panic. And we say, OK, let's look at when the last backup copy was. But that sometimes doesn't work on some systems because of the time difference. We cannot lose even 5 minutes of data on a real-time production database. But with temporal, things are easy. You can easily recover from any accidental data issues. So what you can do is you can fire a query, select star from employee, where system time as of 9:59 millisecond, and it will exactly give you the state the table was before you ran that update. You can fetch the current state, do an insert, and you will be able to recover from that without any without requiring any backup to be in place. Yes, sir. So does temporal have any impact on performance issues? Again, you are storing more data onto your disk. That's the only thing which you need to be careful about, how long you want that history information to be stored. So just keep that in mind. You don't want to keep storing it for an extended period of time. That's all. So I'll try to explain this with a simple diagram. So what the way temporal works is you have your main table, employee table, and when you create a temporal table, a mirrored schema of that table is created inside it, which is called as, say, employee history. If your employee table has 10 columns, your employee history will have 10 columns. It's exactly the mirrored schema, as you can see, the temporal table and the history table. Think about when you're trying to do an insert, what happens? Your data is directly inserted inside your main temporal table. There is no change on your history table at this point. But if you want to do any update, what happens is the data gets updated inside your main table, and the old version gets moved to the history table. That's how simple temporal table works. That we'll look at a quick demo on temporal. Close down this. Any questions? Yes, sir. On your disk itself. Yeah, within your database itself. So the question was where it is stored, right inside your database. So we'll look at a test database which I have just created. So let's do one thing. So let's create a temporal table from scratch. So there's a little change on the syntax. So you have to add date time 2 columns, because if you want to track your changes, you need to see, okay, when till what time your record was active. So SQL Server requires date time 2 columns to be added to your temporal table. And make sure that those are not null. If you try to create it as nullable columns, it will throw out an error. And then you have to mention period for system time, valid from, valid to, with system versioning as on. So I'll go ahead, create a temporal table here. Let's do a select star. So we have a blank table now at this point. Let's look at come right back to you. Let's refresh it. Let's look at what got created. So as you can see here, we have the new employee system version table, and this is how it is different. It spells out system version. Once I expand that, this is the temporal history table. So let's look at the columns which are there on the employee table, and let's expand the columns on the temporal history table. These are mirrored schema. But if you look at the naming on the temporal history table, it's kind of, since we did not specify, it gave some random name. So what I will do is, I will drop the temporal table and give it a proper name. The way you drop the temporal table is, you have to alter the table, set the system versioning as off, and then you go ahead and drop it. So I'm using the new syntax in 2016, which is drop table if exist. I'll go through that in my future slides. But I'll just go ahead and drop it for now. And then I will create the temporal table again. And this time, when I'm creating it, I will explicitly mention here saying that, okay, the history table name is DBO history. So that way, I have good names to my history table as well. So I will refresh this guy. Not this one, let me refresh the database. Now when I expand the employee table, you'll see my history table is named as employee history. So let's go ahead and insert some records inside the main employee table. So I'm inserting 3 records here, employee records. So when I do a select star from employee and select star from employee history, what do you think? What's there in the employee history at this point? Awesome. You guys are awesome. Okay, there's nothing here. So let's delete the third employee. What do you think is there on the employee table now? 2 records. Employee history? Okay, let's see what it has. So the employee 3 is now deleted from the main table. Employee 3 is now inserted inside the history table with a date, valid from and valid to. Let's go ahead and update one of the, let's update the employee 2 actually. Let's change the date. It was 40 currently. Let's change it to 38. Now when I run it, when I check the employee and employee history, the main table has the age updated as 38, and the history table contains the age as 40. So basically, it's capturing what the older version was. Now, think about, if I run select star from employee table, it will always give me the current state of the table. But I have a requirement, and I want to see how the table looked like before I made these changes, how to do that. So it's very simple. I'll just fire a query. Select star from employee for system time as of. So I know that I have never changed the date of the valid employee 1. So what I can do is I can just copy this time, put it here, because I deleted the employee 3, I updated the time on employee 2, but employee 1 was the same. So when I run this query now, I'm running it against the main table, select star from employee, and boom, I get the initial state of the table. So I have employee 1, I have the employee 2 aged 40, I have employee 3 aged 35. Yes, you can do that. It's again data. Think about the same thing. Your table has 1 million records, and now your history table is capturing even more records. So it's just on table size here. Yes, sir. The question is, can we track history for specific columns? No, you can track it for all the columns on the table. So you are actually capturing history for a particular table, not for just for the columns. No. I don't think so. At this point, I think it has to be on the same file group. You can? You've tried it? Okay, that's awesome. Okay.
Where actually I do not really alter data, it still will add an additional record in the history table, right?
If you're updating your main table, yes, it will add another record onto your history. No, only if there is a data change, then it will insert a record into. Okay. I think it will. Yes. If you are running an update query, so it will track changes. Yes. Absolutely. And again, the beauty of this is I just created a new temporal table, but if you already have an existing table, you will be able to actually alter your table and convert it into your temporal table. So it's pretty simple. So I guess I have an example. So this is, say you have an existing customer table and you just want to convert that table into a temporal table. So you add 2 date time 2 columns, and you don't want to break your existing application. So you can just mention an attribute called as hidden on those 2 date time 2 columns. And you can run a query saying alter table. You can change the versioning, and you can mention your history table name. And just a two-step process to convert your existing table into a history table, and it will work out of the box. Absolutely, you can have that. By default, it creates an index on the date time two columns, on the two date time two columns, but there's an option where you can create your own additional indexes. I'm not sure about that. That's a good question. The question was, does it work on partition tables? I've never done that. Yeah. I'll get back to you on this. Good question. Respect to time. Can you come again? Let's try that out after the session. That's a great question. I guess you need this. That's a great question.
I think it will be blocked, but I'm not sure.
For you. So, we'll try out after the session. Actually, we'll run a quick demo and figure that out. Let's move on. Okay, so the next feature, JSON support. Now for developers, we have been working on the front-end side with JSON for a long time. But till 2016, we did not have support in SQL Server to handle the JSON object, right? There were a lot of organizations who were still using and storing JSON as a varchar column on the database because there was no data type called as varchar like with XML. We had a specific data type. So again, for front-end applications, we have been now using JSON. It's the most widely used data interchange format. Gone are the XML days, right? JSON has, the biggest advantage of JSON, I guess, is the fact that it is written in an array format, which gels well with the UI technologies. Like if there is any object-oriented language, JavaScript, so it gels well. It's in array format. With XML, the problem was it's in a tree structure. So the data had to be transformed and then parsed. So there was an additional overhead. Again, JSON is, I just noted down what are the advantages. It's lightweight, it's faster, it consumes less memory. You say it's so easy to parse, it's easier to read. So all the drawbacks which were associated with XML, JSON has, it's just the opposite. So yeah, the question is, how is SQL Server 2016 now helping to the cause? So think about scenarios. You have your UI side, and you have your database here, right? So what do you need in SQL Server? So you need, if you send a JSON object from the UI, you need SQL Server to be storing that JSON object in a relational table format, right? It should parse it, and it should store it inside your employee table, say. The second thing which is required is, once you have your data inside your main table, say inside your employee table, how to transform that data into a JSON object and send it to the UI. So these are the two things which are primarily required. And then inside the SQL Server side as well, if you get a JSON object, sometimes you might need to verify if that JSON object is actually valid. You might need to do some more additional checkings in SQL Server side. You need to, say, modify one of your JSON object. So how does SQL Server 2016 does that? So basically, there are 6 new functions which have got introduced in 2016, which actually does all the work for you. So the first function is JSON Auto. What it does is pretty simple. Let me say you have an employee table, and you want to convert the first 2 rows of your employee table into a JSON object. How do you do that? You just fire a query, select top to star from employee for JSON auto. That's it. And the output of it is a JSON object. So pretty simple to use. Again, remember that there is no JSON data type in 2016. All you have is you have to store it inside a varchar or an varchar column. So from SQL Server side to the UI, you are done. Think about scenarios where you are passing in a JSON object from the UI and you want to store it inside your SQL Server table. How do you convert that into a relational table format? To take care of that, you have a new function, which is OpenJSON. So I'll go through a demo, but again, it's pretty simple. You pass in, you define your JSON object, and then you use this function, which will do all the transformation. There are 4 new functions which are also introduced. So the first one is JSON. So what will happen here is, okay, you are sending a JSON object from the UI, and you want to store it inside the database, but it's always a good idea to validate first if the JSON object which the UI sent is a valid JSON object or not, right? So by using isJSON, you will be able to do that. JSON query, if you want to extract a JSON fragment, say you are sending in a list of 500 employees in your JSON object from the UI, and you just want to fetch and process something on the 50th employee. So you can do that using JSON query. JSON value, what you can do is, if you want to fetch the 50th employee and you want to look at what is the SSN of the 50th employee, you can use JSON value to fetch a scalar value from that JSON object. And finally, JSON modify. If you want to do any sort of modification on the object which you receive from the front end, you can use the JSON modify and play around with that. Again, quick demo to show you how this is actually working. Any questions on JSON handling in 2016? Yeah. So what I will do is I'm firing a query, select top 2 from the person, from the address table, and I'm just saying for JSON auto. So what happens is the result is a JSON string. So it's as simple as that. Just add in for JSON auto, and that should take care of the conversion. Think about, I declare a JSON object. This is the object which I'm getting from the front end. I set the JSON object as address ID, address line 1. So I want to convert it and store it in a relational format inside SQL Server tables. So I will use my OpenJSON function here. And all I need to do is select star from OpenJSON, and it will store it inside in a table format. Let's look at how the isJSON function working. So I will declare a JSON object. It's a valid JSON object here. And I will say if isJSON function is 1, then say that it is a valid, or else print it is an invalid. Again, I have used a valid JSON object, so it says it's valid. The same example, what I will do is I will change. I'm just knowingly removing the colon sign after the modified date. So now I know that it's not a valid JSON object, right? Its syntax is wrong. So when I run that, I'll see that, okay, it recognizes this function that, okay, it's not a valid string. We look at JSON value. And as I said, JSON value, if you have a JSON object like person object here, what it will be able to do is it will be able to fetch the scalar value from a JSON text. So if I want to fetch the last name of the first person, so I can use it like this, select JSON value. You can pass in the JSON variable which you have, and $person0 last name. As simple as that. You just run it, and it should give you back. So these are, by default, inbuilt functions. It works great. There are a couple of modes here. Now, as developers, if you want to throw an explicit error from your database if there are some error handling required. So what you can also do is, there are two modes here. One is the lax mode, and one is the strict mode. So by default, the lax mode is turned on. But if you want to throw any error to the front-end application, you can turn on your strict mode. So let me show you. So you see that I have a query here, select JSON value. I'm passing in the JSON object here, strict person1 age. So what will happen is, so there is no node for age inside this person object, right? There is first name, last name, account number, modified date, but I'm trying to access the age here, so it's not there. So let's run this query and see what happens. So you see the last query returns me an error saying property cannot be found on the specified JSON path. So this is how you do an error handling from the front-end side and return an explicit error if you use the strict option. If you use the lax option, which is by default, so it won't throw you an error. It won't return you anything, but the explicit error won't be thrown. JSON query, let's look at, again, I have a person object. Select JSON query, what I'm doing is I'm looking at the person object here. And the person object has name, first name, last name, and then under the address, it has state and zip. I have a query which says select JSON person 0 age. Again, age doesn't exist. I will just see what it does. The next query is using lax mode. So as I said, lax mode is default. If it is null, if the path doesn't exist, it won't throw you an error. Strict mode throws you an error. So if I run that JSON query, it will return me all the results which I need. So again, the difference between JSON value and JSON query is, JSON value is when you need a specific scalar value, and JSON query is when you require a particular node value or a particular row value. One thing very important, when you are doing any handling of JSON object, again, you might have stored procs where you are validating your JSON object. You will always require to do some modification based on your business logic. At that point, JSON modify is something which will come very handy, which you will be running across multiple times. And the way it works is, you have your person object with name and address. And if you want to modify the address zip code from 24153 to say 35043, it's easy. You use the JSON modify function, pass in your JSON object, and say person 0, address, zip, and what is your modified value. Just run it, and boom, you will be successfully changing your JSON object. So this is, the JSON modify is something which, once you start using JSON in your SQL Server, you'll use it a lot, and yeah, you will be using it. Yeah. Yes, sir. Again, yeah, I haven't dealt with a huge JSON load till this point, but again, these are inbuilt functions. Whatever experiments or performance load tests which I have done, I haven't seen anything, any bottlenecks. But again, you need to be considerate about how big a JSON object you are sending. Say you are sending in a JSON object which has a million records, and then you are trying to fetch some information. Obviously, it will be slower. So.
Are you also supporting the storage of these large objects in single columns?
Yeah.
I've had a problem with that.
Absolutely. So it has to be a varchar max column at this point. So you will have to bear the burden of having a varchar max column in your table which cannot be indexed, and that's the only downside of storing a JSON object inside your database at this point. Or whenever you do any blob storage, you have to use a bigger column size. There's no way around that. On one of the nodes. It won't help. Again, you can create an index on your zip code, but again, it doesn't help you because end of the day, you are still storing your entire JSON object inside a varchar max column, and that's where you will bear the brunt of performance issues. Will you need it? Do you need a computed column? That's the question. I don't think you'll need it. Yeah. I guess whatever I've seen, when you receive that object, you'll always require to parse that and save it inside in a relational format, right? Because you don't want to store it and again bear the brunt of parsing it. So at the first time when it comes into your SQL storage, just save it in a format. So if you have an employee table, store it using those functions, store it inside your employee table as is. So let's go ahead. We have 15 more minutes. We'll go through some T-SQL enhancements. Pretty cool. First one is drop if exists. Again, how many times have you come across a scenario inside your stored procs where you have to explicitly check if your object existed before dropping it, right? You have to write select if exist, select star from DBO employee, then drop it. That was always a pain because you have to explicitly check for the existence. And if it doesn't exist, it will throw you an error saying that, hey, your object doesn't exist. But now, with 2016, you have a cool feature where you can write it all in a single line. Drop table if exist table name, right? If your table doesn't exist, it doesn't throw you an error. If it exists, it will drop it. The beauty of it is it's not only applicable for your tables, it also works well with your functions, triggers, your columns, and you say it, all the database object, it works fine with them too. String split functions, one of the biggest pain for developers. Yes, sir. Yeah. No, there is no equivalent. It's just dropping at this point. Yeah. Does it come again? 16, it does, you're saying? Okay. I have a demo, we'll quickly check that. We'll quickly verify that actually. String split function, what I was saying is, it's a pain at this point till before 2016, because for developers, if you want to do any string split, we had to write our own custom logic, right? You have to write a function which used to take care of the string splitting part. Say you have a string, SQL Server 2016 rocks. How do you do that? How do you split that string? You have to write some functions. But with 2016, all you need to do is there is a string split function. You pass in your string, and as a separator, you pass in your empty string value, and it will say, OK, SQL Server 2016 rocks. It's pretty simple at this point. The only thing which you need to consider is it will only work when your separator is a single character. It doesn't work with multi-character values. Yes, space, comma, those will work. But if you say comma, comma, it doesn't work. It will throw you an error. Compress and decompress function, again, as devs, what we have been doing all this while is whenever we had to handle a blob storage, a big, huge amount of data, and save it inside our database, we know that it consumes a lot of table size. Again, the I/O will be higher because you are passing in and out a bigger storage, a bigger text. So what we do is we use some of the compression algorithms which are available in the market, right? Third-party compression algorithms. ZZip algorithm is one of the most favorite, which most of the developers in the .NET world, we have been using it over a period of time. But it required some custom coding for sure on the front-end side to do the compression and the decompression. But with 2016, we have two new functions, compress and decompress, which actually does the same thing. It will use the ZZip algorithm behind the scene, and it will do all the compression and decompression. Pretty cool, powerful feature, out of the box, no need of doing any changes in the UI. It just works beautifully. Date_diff underscore big function. One of the biggest problem with the date_diff function was whenever you have a date to compare, the start date and end date, if it was kind of huge, which is over the integer limit, you used to always throw an arithmetic overflow exception. So it was like, okay, I'm in the mid of a stored proc and it throws me an error, arithmetic expression error. So with 2016, they have just modified it, wherein the return type of date_diff underscore big is a big int now. So instead of int, it returns a big int. So obviously, you will never have that problem of an arithmetic expression overflow error. We'll look at the demos in some time. I'd like to wrap up the security feature. So we have three new features from a security standpoint, which got released with SQL Server 2016. We had always encrypted, which was an end-to-end encryption. We had row-level security, and then we had dynamic data masking. So just go through dynamic data masking. I found it very beneficial. We have been using this masking thing on our projects. We have been writing some custom logics to mask few of the sensitive information over the period of time. This takes out all the pain. So what is dynamic data masking? Basically, a new security feature which is inbuilt inside SQL Server 2016. So what you can do is you can basically mask it on the fly. Say you have sensitive information stored inside your database, right? SSN information, employee phone number, employee email. When auditors come in and they'll say, hey, you all have the developers who are working in your production environment, they have access, read access to your entire database, so they are able to see all the sensitive information. So at that point, what do you do? How do you stop? Again, developers don't need access to sensitive information. If you are say your application has a customer care portal or something, they don't need to see the sensitive information. If you have your users in the UI, they even don't need to see the sensitive information. Sensitive information should be seen by only authorized users. So with dynamic data masking, it's so very easy. You can authorize, say, okay, your DBA, your sysadmin, or even selected users, they are the only ones who can see all the unmatched information, and all the others, they will see matched information. You can define your own masking functions and how you want to display your values. Say SSN, if you don't want to display the entire SSN, you can say 1, 2, XXXX, and just put the last number. I'll show a demo about it as well. Okay, so again, it's not a replacement for encryption. It doesn't change any information behind the scene. Always encrypted is the one which is the most secure, but again, depending upon your project, your requirement, you can try and use any of these three security mechanisms. You had a question? So the question is, will you be able to filter on those columns? You will be able to filter, but you won't see the unmatched value. So if you are inside the group of unauthorized users, you will just see the unmatched value all the time. You can? You won't be able to guess the value. We'll see in the demo. Let's see how it works. So how do you actually mask the values? So there are four inbuilt functions which are there in 2016. First is the default function. So whatever column you want to mask, say you want to mask the entire SSN field, so everything will be X'd out on that field. Email functionality, if you use the email function, what will happen is it will put your email inside in this format, axxx@xxx.com. Partial, which is like the custom masking function, what will happen is you can specify how you want to do your custom masking. You can say that I want to display the first 2 digits, I want to display the last 3 digits, and I want to X out the rest of the information which is below it, which is within it. So you can use the partial function there. And you have the random function, which is like, if you want to, if there is an ID, primary ID, and you don't want to display that ID in the UI, you can just mask it, say, give any random number from, say, 1 to 10,000 and kind of display it. Yes, sir?
Is this one-way masking? Can you unmask it?
It's only read. Yeah. So the data is not masked. So it's just on the read side where you will see unauthorized users will see masked data. But if you're authorized, you will see all the unmasked information. So kind of put it in an image as to how this works. So how does dynamic data masking work? You have your security officer. You can say it, he is the person, DBA, who takes care, who defines the data masking policy in your application. And then you group your users. Say you group them into 2 groups. Say one is the admin and one is the unauthorized users. So when an admin looks at your employee table, he will be able to see all the unmasked information like the phone number, emails, SSN. But once your unauthorized user looks at it, they will be seeing just the masked information. The data doesn't change in the behind the scene. It's just a read-only masking which happens on the fly. Yep.
So if I'm not an authorized user, then can I search this information for a particular column, like an SSN or something, even though you maybe just the first 4 numbers, but I can still search. Can I still search for a street number?
Yes.
And get a result at the end.
Yeah, you can still search. It's there. It's masked information. So let's open up, look at a quick demo of dynamic data masking. So we'll look at, I have a temp table, test DB. So I'm creating a new table and defining some masking functions here. So I have a customer table, and I'm creating, it has all the columns, last name, age, phone number, email, SSN, credit card number. But as you see here, I'm defining the masking policy when I'm creating this table. You can create it on existing table as well. You can do an alter and add your masking function as well. But look at it, the way to define it is just add masked with, function is equal to default. Masked with function is random, partial. So I've just tried to use all the 4 different functions here for the demo purpose. So let's go ahead and create this table. Okay? Let's insert some data here. Let's do a select star. Okay, I have all the information here. You can see all my credit card information, the SSN information, phone numbers, everything. Let me create a test user and just grant him select only access on this table and execute the select query now. So I'm running it. And what you see is, since this new user has just select permission, I'm now seeing all the matched information inside my tables. I see my last name X'd out, phone number, email, SSN, credit card number, all is X'd out. So again, you might end up masking a number of columns inside your database. How do you keep track of all those? So there is a DMV masked columns, which you can, if you run this query, what it will do is it will tell you, okay, all these column names inside this table are masked, and what are the different masking functions which are getting used inside your entire table. If you want to alter an existing table, you can just fire a query, alter table, table name, alter column, and you can add your masking function. So again, this is, I just took for the demo purpose, I just gave him the select only access, but you can create your own groups as well, and then do your authorization on those groups. Say, yeah, you can define a permission on them, just say select only, so that will work. I guess, yeah, any questions? Same thing. You can create your own new user groups, add in users there, and then give them access, read-only access on the main level, on the main user group level, and that will work. So.